For this video, what we want to do is we need to subtract our two polynomials. So there's a couple ways we can do this. First of all, the main important thing, guys, remember we talked about like terms. You can only subtract like terms when they have the exact same base and they have the exact same exponent. So therefore, I notice I can only subtract a 7z squared from this 3z squared. Why? Because they have the same base, which is z, and they have the same exponent. The 4 I can only subtract from this negative 5. I cannot subtract just my regular I cannot subtract z from anything because there's no z over here. So you're just going to have to leave that one out. So there's a couple ways you could write this. One is I like to always write the kind of the vertical method, which means I'm going to line up your problem with like terms. And it's easiest usually to write them out in standard form. So let's write both of these out in standard form before we convert them. So this one has the highest exponent first, 7z squared. However, then you should write your variable, which would be next, plus 4, minus. Now remember, our constant always goes last, so our 3z squared is going to go first. And then we look at a problem, we have an issue, right? We don't have a z, right? I have a z in this one, but I don't have a z in that one. So one thing that I can do to help me out is I can kind of give it a placeholder. So I could write, if I don't have a z, I could theoretically write z times z to the first power. Well, what's 0 times z? 0, right? So I could theoretically write that in because we don't have one there. And the reason why I'm going to do this is just to kind of help you guys out, to give you a kind of a placeholder so we can solve the problem. And then minus 5. Okay? So now what I'm going to do is I'm going to line these up vertically. So the first ones I'm going to have the squareds, z squareds, the z's, and then the constants. So what I do is I take 7z squared minus z plus 4. C remains for constant, or the numbers. Got it? Then the next one is I'm just going to write minus 3z squared plus z minus 5. So just like when you guys first did subtraction, all I did, if you guys noticed, I created vertical subtraction problems with all the like terms. Does everyone see how I did that? So now, simply what you do is just subtract. So 7z squared, that's z squared. 7z squared minus 3z squared is 4z squared. Negative z minus 0z, it's pretty much there's 0 of it, right? Is just going to be minus negative z. And then 4 minus a negative 5. Let's take a look at what that looks like again. 4 minus a negative 5. That's what we call a double negative. So therefore, Zach, double negative is going to become a positive. So it's going to be adding. So it's going to be 4 minus negative 5 is going to be positive 9. And that's it. That's your final answer. Okay? If you guys want to look at another way to do this, rather than subtracting, I usually like to add. So what you could do is do the exact same thing that I just did, but rather than subtracting, you're going to have to add. Well, how do we rewrite a subtraction problem as addition? Think about this. 7 minus 4 is the same thing as 7 plus a negative 4, right? So what I need to do is I need to distribute that negative sign to all three of my terms. So I can rewrite this as a negative 3z. Obviously a 0z, so minus 0z, doesn't really matter. And then that's going to be plus 5. So therefore, when I do this, I'm still going to get the exact same answer if I choose to add and use the distributive problem. Well,